A little quiet, please. No conversation.
Thank you. This is something you can't see ever. If you were looking at the moon through through a telescope, and you set your time-lapse camera on a particular part of the moon, you would see over a period of an evening, the moon would change the shadows because, in fact, the moon is going around the Earth, and so sometimes it's day and sometimes it's night, and you see the shadows here shortening or lengthening. But you can't take a picture like this from the Earth. So the only place you can take a picture like this is nowhere. So what they've done is they have a lunar orbiter which circles the moon again and again, many times a day, taking pictures of the moon all the time. And since they have, I don't know, millions of pictures, they have selected for each of the frames that we're looking at multiple shots of the same spot, so they can show you again and again the same spot as the shadows lengthen or shorten. So it's a feat of digital engineering, but and photoshopped, I'm not sure that's appropriate.
Well, but by Photoshop, I was using it generically that you're changing content, and they're not changing content.
They're not changing the content. This is real. Look at the length of the shadows. That is beautiful. And this, by the way, is Mare Orientale, which cannot be seen from the Earth hardly at all. This is just beautiful. I'm just going to speed this up. This is regular speed. I'm going to now speed it up to 2 times speed. So we're going to be talking about the moon today. We're going to talk about returning to the moon today. Isn't that amazing?
The definition is extraordinary. I mean, how do you...
Because it's in fact a very high definition camera in orbit around the moon. So this is a better shot than anybody could ever see of the moon. But they're going back to the moon. The Americans and the Chinese and the Israelis are just sending something to the moon. They're just going to play on the moon a little bit, but they're not sending any. We're planning to go back with manned spacecraft, and although we're all pretty old in this class, there's a good chance that most of you will survive long enough to actually see some of this actually happen. There is a lot of stuff that's going to be happening in the short term.
Is this NASA or private?
There's no such thing as a perfect writer. This is why I use.
That's NASA. But who's going to the moon? NASA's going to the moon. But unfortunately, NASA has made an error, and it's not willing to say that it did. And so what happened was President Obama decided he didn't like the space program. So what he did is he cut the construction of this giant rocket that would be needed to get us to the moon again. And there was a lot of controversy about, oh, you can't do that, it's horrible. So it turned out that they went back and they said, okay, we'll build it. But then they didn't go ahead and build the big one that they were going to build. They decided to build a smaller one. This smaller one can't do the same thing that the Saturn V did, take us to the moon and bring us back in one shot. So this one can't do that. So they changed the mission. The mission of this new rocket was to go to an asteroid and go and pick up a rock, bring it back to the moon, in orbit around the moon, and after it's in orbit around the moon, astronauts would go visit this rock and they would chip some pieces off the rock, and they would put it in their little sample bag. But there's the rock in orbit around the moon, so they needed a place to stay. So they decided that we would build a place for this rocket, which can't land on the moon. It would build a space station in orbit around the moon. Then the astronauts, when they brought this rock back to the moon, they would have a place to stay while they were busy playing with the rock. So a space station around the moon was conceived of. All sorts of plans were made, and the only problem you see here is you see this rocket, this automated rocket, has gone to an asteroid and is busy picking up a rock. This is the design. It's a very cute design. The rock is right under its feet. Okay, so it's picking up the rock, and now it's lifting it up, and then it'll examine it a little bit, and then it'll. It's happy with it. It's taking it, and then it's going to take it away, and it's going to bring it back to Earth and to the moon. Very happy.
It's going to land on the moon?
Now it's going to land because they don't have that sort of technology. So it's just going to bring it back to the moon in orbit around the moon. Okay.
And what's the purpose of that?
So we can examine this rock. Okay. That's the mission. Bring a rock back from an asteroid, big one, okay? But you can't bring it to the Earth because we can't, it's too big. So we're just going to leave it in orbit around the moon, and we'll visit it as we leave our little space station hotel to go visit the rock. Okay, we'll go back and forth, visit the rock, and that'll be our job. It's a great idea, except it's sort of dumb. It's sort of dumb because it's not a bad idea for science. It's a great idea for science. It's just dumb from the point of view of nobody's going to get excited about this, and we're going to spend billions and billions of dollars to do it. So everybody said, let's not do this, and they canceled this program. But they already had on the drawing board the hotel that the astronauts would stay in. Okay? The hotel is still on the drawing board. The hotel, now the astronauts are going up to visit the hotel. Okay, so they're docking with the hotel. I'm calling it a hotel. And they're calling it a robotic vehicle in this case, and they'll be fooling around with it. So they canceled the program. They didn't cancel the hotel. Now the United States has decided to reuse the hotel for another purpose, and they're calling it, let's see, what are they calling it? They're calling it, very nice name, LOP-G, which I'm not quite sure what it means, because I keep forgetting. See, they're taking a sample from the asteroid, see? And they're putting it in their little sample bag, and then they're going back to the hotel. All right. So that's the idea, but the idea has been canceled. Now, the United States has decided to use the hotel in their return to the moon. So it's called the Lunar Orbital Platform - Gateway, and the United States has decided that it makes a lot of sense before you go to the moon to stop off at the hotel, maybe have a little bath, hot shower before you go to the moon, okay, and waste 30% of the fuel in the process of doing it. And because this hotel needs to be quite robust, it's going to be 1/4 of the size of the International Space Station. It's going to cost billions of dollars, take years to build, okay? And as I'm obviously editorializing, it is completely unnecessary. Now, this, of course, is not the opinion of NASA. It is, however, the opinion of the Chinese. It is the opinion of the Europeans, and it is the opinion of many Americans, but not NASA, because you know you got to be loyal to your group. Let me tell you why this makes no sense. first of all, let's see what it in fact is. Okay, for example, let's see. This is the important part of this business. This is the orbit of that hotel. Okay, there's the moon. The Earth is staying one place in this video, so it's always here. The moon is there, all right, and this gateway is in fact doing a number that you can see. It's not exactly, it's orbiting the moon, but it's going to the moon and then away from the moon and then to the moon and then away from the moon. So, but look at the shape of the orbit. It's kind of like a rectangle. So they call this a rectilinear orbit. Okay, what is the purpose? Now let's roll this thing back a little bit and let's see again what's going on here. Instead of looking, oops, that was way too much. I started the video in the middle, so okay. Okay, so over here you can see another way of looking at it. In this frame here, the moon is stationary. Okay, the Earth is moving around. The moon is stationary. Now you can see that it's going away from the moon and towards the moon and away from the moon. And this is a very, very nice orbit. Everybody likes this orbit. It's a great orbit. It's a very smart orbit. Very useful. There's the Earth going by. It's great because it requires very little fuel to do this, because the Earth would otherwise be messing with this orbit, because the Earth is there going pull, pull, pull. But this orbit is very, very stable, and you can keep doing this using hardly any fuel. So the hotel, the gateway, is going to just be happily staying there. The nice thing about this orbit is that it has a special property of being able. See, I stopped it now. When you're all the way over here, okay, and you're sort of at the top of your arc, and while you're at the top of the arc, you can literally change direction and go that way, which means that you're not in the same plane going around the moon all the time. You can go around the moon anywhere you want. So literally, this is a jumping off place for any place on the moon. It's like base camp for climbing to the moon. Anywhere you want to go, start here, change your orbit a little bit, just a teeny bit of fuel, and you're someplace else. So this is a great place for exploring the moon. That's one of the arguments. And what you're going to do, because it's a good idea. What you want to do is, for instance, remember they left the LEM. They took off from the moon, and they had this lunar excursion module, and then this lunar excursion module burned up in the Earth's atmosphere. What a waste of an entire spacecraft. Well, why not have a thing that can go back and forth to the moon from here? That makes a lot of sense. That's another argument for it. Why not have something that goes back and forth? So you have things that you have astronauts come in this big ass vehicle to here, and then they board this lunar excursion module and they drop to the moon. They come back. They go. So it makes some degree of sense. The part where it doesn't make sense is that there's no reason you have to do that. You can simply go to the moon. You know, it's why stop at 90% of the way there? Go to the moon. Okay, if you want to park a spaceship in orbit around the moon, do that. Put a LEM in orbit around the moon, leave it there, and come back. You don't have to take it back with you like the astronauts did on the Apollo. Direct to the moon makes much more sense, and we're not going to do that. So we're going to first build a space station. That's going to take us years and years and years to do it. It's not that hard. It's expensive as hell. We don't have the right thing to build it with. Let me show you. Yeah. So this is what we have. We have some things. Elon Musk is messing around with this thing all the time, and he's being very successful at this thing, and it can bring 22,000 kilograms into low Earth orbit. But the Apollo Saturn V could bring not 22 but 140,000 kilograms into low Earth orbit. And what are we building today? We're not building this. We're building this. And this can build, well, it's 130,000 pounds. That's not 140, but it's 130. And we're planning to launch this thing, which is pretty good. But we haven't launched it yet. We've been building it since the Obama era. And we still haven't gotten it out of the hangar. We have something that looks like this. We have something that mounts up there, but we don't have anything that works yet. And this costs billions of dollars. Elon Musk is building this. Is also building this. Okay, so the Falcon Heavy was the one he launched the Tesla with. And it can lift 63,000 pounds into low Earth orbit. But this guy, which he's sort of building, can lift 250,000 pounds into low Earth orbit. So this is the guy that may eventually be the thing to use to really get us to the moon, possibly. We could get to the moon with that. We could build a space station with that. This thing, I don't know, can we build a space station with this? We haven't launched it yet. This one already has launched the Tesla. So we don't really have the technology to do it. It's expensive, and NASA is dragging its feet because it really is underfunded, this thing. Okay. So why would we go to the moon in the first place now? The reasons are we can begin to build space colonies on the moon. We don't have to, as I said, go there and build it using a space station. We can do something like this. There's a space station. Okay. Hold on. I'll show you. There's a very smart guy. His name is Zubin, and he is of the opinion that you can get to the moon and build a base there using 3 Falcon Heavy launches. The first one lands and supplies. The second one lands and supplies of habitat and food and spare spacesuits and other tools. And then the third one goes, this is a Falcon Heavy. We already launched the Falcon Heavy. Okay, we don't have to do anything special. There is a Falcon Heavy. And then we can put 2 men on the moon and a lander, and they can go. So that's your first lunar base, and we're there, and you can do this in 3 to 4 years. But the United States is going to take 10 years to do this, and in the meantime, the Chinese are going to be there, and the Europeans are thinking, I don't know, hanging out with the Americans. Maybe we'll go with the Chinese because the Chinese have given them an invitation. Play with us. I need to. Would somebody close the door back there? Thanks. So on the moon, this is what you do when you get to the moon. There are places on the moon where the sun don't shine. literally the north and south poles of the moon, the craters are so in shadow. You saw the shadows in that video at the beginning of the movie, the session. But the sun don't shine, which means that anytime there's any bit of water that hits the moon, and there's always water hitting the moon, because most of the asteroids and the meteorites have water in them. So when you land a meteorite on the moon, it's got water in it. If it lands in the shadows, the permanent shadows, it carries water to the moon. You can go to those places where the permanent shadows are, and you can mine for water. Water is made of hydrogen and oxygen, very flammable when you burn them. All you have to do is separate the hydrogen from the oxygen using electrolysis of some sort, using the rays from the sun to power a solar array, which then provides the electricity to electrolyze the water, and you've got fuel on the moon to essentially create a colony that can go back and forth to the Earth anytime it wants to. But you have to get to the moon to mine this stuff. The Chinese know this, and they'll be there long before us. And they're going. Of course, there's only a few places you can go, so they'll be going to the best place first. They'll be going to where the mother lode of water is, and then they'll be there, and they'll just they'll take all. Now, it's not easy to do this, believe me, because for one thing, you get the solar array here, but the water's over there in the shadow. You mount your solar array in the sunlight. You could maybe mount it at the rim of the crater, but you still have to create electricity down there. You still have to get the water out of the ground. How do you do that? It's frozen solid. It's frozen solid, and you're not going to be at it with pickaxes, not anytime soon. So the best thing to do is you take the sunlight, you beam it in that direction where the sun don't shine, and then you heat it up. It boils the water, makes steam. You capture the steam, and that's how you do it. It's not easy, okay? This is not an easy little thing to do. Nevertheless, it's the thing to do, and the Chinese will be doing it in 10 years. We will be as soon as they start doing that, we'll be on board.
So you said if they split the water, they would have fuel, so it's hydrogen?
Hydrogen and oxygen, yes. Now, I did lie about that a little bit, okay? No one has ever built a hydrogen-oxygen rocket because nobody. The problem with hydrogen is it's big, okay? You can't really compress it down without cooling it off to almost absolute zero. So mostly it's a gas or a liquid, and it takes a lot of volume. So they don't launch any hydrogen rockets from the surface of the Earth. So they have no experience building a hydrogen rocket. So what they would do is they might bring methane to the moon and just use the oxygen, because rocket fuel can be and usually is methane plus oxygen. So they might bring the methane and use the oxygen from the moon. So that may be what they actually do.
And the oxygen is for combustion?
Yeah. So the commercialization of space has begun in so many ways in the last few years. I want to show you the commercialization of space. This is a little app. It's really cool because what you're seeing here, see that little ball in the center of that disc of pebbles? What you're really seeing is the Earth surrounded by the satellites that are currently in orbit, and these satellites in this simulation are the actual satellites in their actual positions at this very moment in the sky. So let's see. Let's see the satellites that are operational. Those are the satellites that are currently operational. Apparently, there's 900 that are showing in this, maybe more that are actually operational. There's 900 satellites that are currently, and I can speed this up. Let me do this for the fun of it. I can speed the things up, and now do they move? Yeah, they're moving. See, they're moving. It's real. These are the operational. These satellites here are the satellites in geostationary orbit. And what that means is they are exactly so far away from the Earth that their orbit around the Earth takes them exactly 1 day to go around. It takes them 1 day to go around the Earth. The Earth spins around its axis in 1 day, so that they're always over the same spot on the Earth. So when I look up right there, there's a satellite there, most probably, given the fact that there's satellites everywhere. There's probably a satellite right over my head. Well, actually, at the equator, which way is south? It's at the equator, so that way I think that way is south. And so there's a satellite over there, and it'll be there now, in 10 minutes from now, an hour from now, a day from now, a week from now, a year from now. It'll still be right there. Yes. Yes.
So that must mean that there are spots that are not visible.
That must mean that there are spots that are not visible?
Yes, because satellites stay in one place and there aren't millions of them.
No, satellites stay in one place, but I'm not sure what you're saying.
I'm saying that it's not covering every inch of the Earth.
It's not covering every inch of the Earth. It's just at the equator, these geostationary satellites. If they were not at the equator, then they would go whoom, whoom in the sky. They would go north and they would go south. And they would never be in the same spot in the sky. The only way you can be in the same spot in the sky is if they're at the equator.
So there still must be spots that
All the other spots, all the other spots are in fact not good places to put a geostationary satellite, and so they don't. So these are communication satellites. Sometimes you make a phone call and you hear these delays, or they're on television, right? They're on television and they're talking to the reporter and hello, and then half a second later they respond. That half a second is the time it's taking the light to go to the geostationary satellite and back down again. So it's sort of built into what we understand these days. The reporter gets his information half a second later. But that's these satellites. It could be weather satellites, it could be military satellites, it could be all sorts of different reasons. They've launched this number, which according to this is 900. In the simulation, there's probably many more that are not being shown. But look at this. This is the non-operational satellites. These are satellites which have ceased to be of any value to man or womankind. They are in fact either not performing their mission, they're dead, defunct in one way or another. And you can see there's a lot of those satellites out there, geostationary satellites, as well as the Earth is just covered with them. And there's more than this. This is showing 17,000 satellites. But there are millions of satellites. Most of them are pieces of cosmic junk. So for every satellite that's up there, there is 1,000 other satellites, or even 10,000 other satellites that are just little pieces of things that we left behind in Earth orbit. And you may not think that's very serious, but it is very serious. Imagine that you're you got this thing going around the Earth, okay, and you're going around the Earth. So you're going around the Earth like this, and it doesn't seem very bad because you're both going in the same direction at the same time. So basically, your differential velocity is hardly anything. So it's not dangerous, right? Because you're both traveling at 18,000 miles per hour, but you're going in the same direction. So that's not a big deal. Who cares, you know? But after a while, the satellites don't stay in the same orbit, the little ones. And they get deflected and they move. Little bit by little bit till they're going in the opposite direction. Now, one satellite's going 18,000 miles an hour, and the other one's going 18,000 miles in the other direction, 36,000 miles per hour. And when they hit, even the smallest paint chip can poke a hole in a window on a spacecraft. And these little paint chips are poking holes in all sorts of things all the time. Space station is being hit all the time by these paint chips. And it could be getting worse.
We're doing the same thing to space that we're doing to the Earth.
Right. We're doing some nasty things. There was a time, fairly recently, when about maybe 5 years ago, a spacecraft of ours, by accident, hit a spacecraft of theirs, Russians, totally by accident. The two spacecraft slammed into one another at these enormous speeds and broke into thousands and thousands of itty-bitty particles, which are up there. And at one point, the Chinese decided that that would be a lot of fun if they just practiced destroying a satellite in the upper in orbit. So they did that and blew up a satellite and added more tens of thousands of pieces of junk up there. So there's lots of junk up there. And this junk that we put up there that in fact needs to come down. The ones that are all the way up here, they're never going to come down. It'll take millions of years for them to come down. These will take tens of thousands of years to come down. Unless you put a rocket motor on these things, and when they're finished their lifetimes, you deorbit them, they're going to stay up there forever. So that's what people do these days. When you launch a satellite, you put a little rocket motor on it so it can deorbit after its job is done. So that's people are behaving nicely, mostly, more or less. But we're planning to launch a lot more satellites, a lot more. We just begun to do this. So if these satellites keep hitting each other, there's something that can happen in which little pieces hit other pieces, and you get a profusion of little pieces, so that eventually you get so many that the Earth is covered. Trying to here.
Solution before the Kessler syndrome.
So there's a thing called the Kessler syndrome. And the idea is all these pieces hit all the other pieces, and they just balloon. So that everything's hitting everything, and the more pieces there are hitting more pieces till the Earth is just covered with itty-bitty junk. And you can't send anything through it, because there's so much junk that basically we're marooned on Earth forever until we figure out how to clean up the junk, when nobody knows how to do that. So this sort of thing where the Earth gets completely covered in junk, which is called the Kessler syndrome, is not trivial. The guy Kessler is named after Kessler because he figured out exactly how much junk it takes to do this, and we're not far away. But nevertheless, we're launching more satellites. The first thing we did a while back, we launched satellites for all sorts of reasons. Let's see what that Iridium collision looks like. So these are Iridium satellites, and this is the Iridium 33 satellite, and that's the Cosmos 2251 satellite, and this is what they did. Boom. Pieces in all directions, debris not to scale. This actually happened. So if that can happen, what could happen if you put too many of these things up there? Let me show you what the Iridium, they call it a constellation. So this is the Iridium satellites. You were talking about coverage. These satellites are not in low Earth are not in geostationary orbit. They are in low Earth orbit. They move around the Earth once every hour and a half or so. And each one of them has a footprint that it can look down upon, that it can see anybody who happens to have a phone. Hello? Hello? Well, they're talking to that satellite. I could take out my satellite phone right now and make a phone call, and one of these satellites would be overhead at any given time, and I can make a phone call. And how much does a phone call cost? Well, the cheapest plan is $2 a minute, and the most expensive plan is $1 a minute. Nevertheless, I can buy a satellite phone and be in contact with every place on Earth from any place on Earth. That's amazing. It's worth it. You don't need to chat. Hello, I'm alive, send help is all you need. My brother has one of these. He climbs a mountain every week, and he's decided, he's crazy, but he's crazy in a good way, and he carries now a satellite phone with him so that he can be tracked, and in case he hurts himself, they can find out where he is and send help, and he can call and ask for help. 66 satellites. I think it's 11 orbits, each one contain 6 orbits, each one containing 11 satellites. Covers the whole Earth. This was done, well, let's say 20 years ago. 20 years ago, they had the idea to do this. It was a great idea. Let's send up satellites, satellite phones, let's do the whole thing. One little problem, wasn't going to make enough money. So the company that built the satellites went bankrupt, which was a good thing because somebody else, another company, bought it for 10 cents on the dollar, and the satellites were already up there. So they didn't have to invest all the money in putting them up there, they were already up there, and then the business made a profit. And then after the business made a profit, they kept it going for another 20 years. These satellites, all of whom have been launched by Elon Musk, every one of those satellites that's up here in this picture was launched by him, and this is the new generation of the Iridium satellite constellation, and it's servicing us this very day. You had a question?
Going back to the original satellites that are basically in one orbit around the equator. So when they collide,
The geostationary satellites, yeah.
when they collide,
They don't collide.
or when you said China,
I shouldn't say they haven't collided, right?
Okay.
Yes.
suppose they do,
Suppose they do.
a bunch. Will all of the debris stay in that orbit, or will it go all over in different orbits, or will the pieces fall to the Earth?
Very good question. Will the debris stay in orbit? Will they go into different orbits, or will the debris fall to Earth? You saw in the simulation that I showed you just there that when the two satellites hit each other, the debris went off in different directions. So that is what's likely to happen again. The debris will go off in different directions, not necessarily at high speeds, but it still will go off in different directions, and will in fact change its orbit so that instead of going this way, it will go this way. And when it does that, the speeds will be such that they could easily damage the satellites. So yes, it's dangerous. It hasn't happened yet. They control them very well. They know what's happening, where they are. And so the chances of collisions is less because 23,000 miles up, space is much bigger. And while there's maybe hundreds of these satellites now, there's less chance of them hitting each other. So it is unlikely. They may tap each other, but they're not likely to collide.
If there are enough going around this orbit, at some point would they be blocking the sun? Impact climate and so on.
Would they be able to block the sun? No.
Even if it's small.
Even if it's small. You can make a calculation and how many would it take to block the sun? Okay, there is a finite number of satellites that it would take to block the sun. I'm going to do that calculation in my head. I'm going to say billions. Okay, so they have hundreds up there. So billions of satellites would be required to block the sun, maybe trillions, because they're small. They're small, and space is big. And so, well, actually, maybe it isn't trillions. Maybe it isn't even billions. It's this big, okay? The satellites are maybe bigger than this, and it's a circle 23,000 miles in radius. So you can calculate what the circumference is at 23,000 miles, and then that's a length, okay? And you know the length of the satellite, okay? So you could figure out how many satellites fit in that circumference around the Earth. And that's not billions, but it's certainly millions. Okay, so it would take millions of satellites to do that. I did a better calculation. And if I put it on the board, we could actually come down to exactly how many. So that's the Iridium satellite constellation, and 66 satellites with some spares that are already up there. So there's actually 77 up there, because each satellite that's up there has a spare in its same orbit, so that in case one of the satellites fails, they can quickly move a satellite into position. Just like if there's a power failure, the power pole goes down, they can put up a new power pole very quickly. So this is guaranteed service everywhere on the Earth. $1 a minute. Yes.
Isn't the GPS network even denser because you have to have what 3 or 5 at the same time?
Right. Absolutely. So your phone. Oh, there's my phone. Your phone is listening to at least 3 satellites, and those 3 satellites are overhead any given time, and sometimes even more than that. So this is 66 satellites. The GPS network has even more than that. That's just telling you where you are and how to get from A to B in your car, or directions on your phone. So there's lots of satellites up there. This is just the Iridium satellite. And the reason I put this up is because there's a constellation of these that this looks like, but there's another constellation that Elon Musk is involved with again. Not only did he, you know that Elon Musk is doing, he just laid off a lot of workers, right? Why did he do that? Because he has some extremely, and I really mean extremely, ambitious plans that he plans to execute in the next few years. This is the most amazing project, and it's all Elon Musk, and this is now. I'm going to play the whole thing for you, okay? And I'm going to just comment it as we go. The commentary is being delivered by a robot. I don't know why, so the inflection is a little bit off, but it's reasonable to have it narrated by a robot because this is all going to be done robotically. This is
1,500 satellites arranged into 32 orbital planes with 50 satellites in each plane. Because of the orbit's coverage density is much greater in latitudes near 50 degrees north than it is near the equator. The satellites are all at the same altitude, so an important property is the phase offset between
This looks like
orbital
science fiction.
planes. If you get this wrong, the satellites collide, which would be bad. Simulation shows that the best phase offset is 530 seconds. Looking upwards, there are many satellites overhead at any one time. The SpaceX FCC filing indicates that satellites are reachable down to as far as 40 degrees.
I'm going to pause it while I try to deal with the sound.
This can give 30 satellites overhead and are reachable at any time.
What is this? I didn't introduce it. Where's the what's going on here is Elon Musk has decided to not just rule space, but to rule the Earth as well. He's building an internet in the sky. When you make a phone call, when you use the internet these days, you're information is being transmitted over fiber optic lines from here to there and anywhere in the world. And you know, you can call anywhere in the world for ridiculous prices, and your phone calls in the United States are free. All right, the internet is carrying your phone calls. There's no the copper wires that used to carry your information is being now transmitted via fiber optic wires, and that information is underground. And if you need to put more wires in, you need to put them underground, and that takes a lot of digging. But space up there is free. And what happens if you could launch those things on very tall telephone poles up there in the sky and connect every place on Earth with every other place on Earth with satellites in the sky? So he has filed I'm going to press this now and let it play, but I'm going to
There are 5 laser links per satellite to communicate with other satellites. The satellites ahead and behind on the orbital plane stay in the same place in the sky, so these are good candidates for the first 2 laser links. Satellites in the neighboring orbital planes are also fairly static, whereas satellites in crossing orbital planes pass.
So this satellite, which is over this spot on Earth, okay, this satellite, you can reach this satellite because it's in low Earth orbit with a very small device, something about this big, okay, which means anybody in a desert in Africa can have such a device and create a ground station that can pick up the laser link and put it into their local network on the ground. This is a backbone he's building. This isn't for phone calls. This is just the backbone which connects to the local network on the ground. So this is just to carry the bulk of the traffic before it gets divided into the bitty bits that you end up with your phone. It's just the big wires. And so this satellite is communicating with that satellite, and they are moving together, so they're always together. This satellite is connected with that satellite and this satellite as well, because these are always more or less in the same spot. So these 4 satellites can be 5 satellites can be communicating with each other, and this other little satellite here is going in the other direction, so it's moving. So as you watch the video, you'll see the connectivity of these satellites. And how are they connecting? They're connecting with
Pass by at
lasers.
7.3 kilometers per second. As much of the population stretches around northern temperate latitudes, more long-distance communication goes east-west, so it makes sense to connect to neighboring satellites to the east and west, rather than to the nearest neighbors. This leaves northeast-bound satellites talking to their neighbors and southeast-bound satellites talking to theirs. We use the final laser link to communicate with satellites in crossing orbital planes. Here we can see how all the side links.
Look at that. The Earth is going to be covered with satellites with that kind of mesh in a couple of years. Elon Musk's satellites. Why is he laying off workers? Because this is expensive. He's already designed the satellites. He's already got 2 up. Right now he's got 2 up. Tintin A and Tintin B. And he is planning to launch thousands of more satellites in the coming years. So by 2020, 2021, 22, and you will be alive for this. This stuff will be up here. Can you believe that? This is insane.
And what exactly will it be doing?
It will be carrying your phone calls. It will be carrying your data. It will be carrying your TV. It'll be carrying everything that's currently being shuttled under the ground.
Under fiber optic.
Right.
So
yes.
they're going to switch what's being done fiber optically into space.
Right. They're not going to switch it. He's adding more
He's
capacity.
adding more.
Right. The switches. By the way, there was the technical term for this thing is switch. The switches decide which way to go. When you are talking on your phone to somebody someplace else, there are packets of data, meaning your voice, being sent to your neighbor, but they don't always travel in the same direction. Sometimes they go this way, sometimes they go this way, sometimes they go this way. And so packets from your own voice go in different directions, get recombined when you get back to your phone, and it all sounds pretty cool, but the packets have taken independent directions depending upon what the switch decides to do at any given time. You had a question.
Well, so your brother has a satellite phone.
Yes.
He's working off Iridium.
Iridium, yeah.
So
My brother,
how
yeah.
is this different from Iridium, or why can't we just use Iridium? Is
Oh,
it not
Well,
comprehensive?
no, we use a satellite phone is a satellite phone. It doesn't look like a cell phone. It's
Okay.
bigger. It's got a big antenna, and it's much more expensive.
So this is more.
This is not for
comprehensive?
phones.
It's not-
No, it's for data.
This
Data.
is for data.
Data. Your voice is
Oh.
data
Okay.
as far as the internet is
So
concerned.
this is the internet.
It's the internet.
Okay.
And your voice could end up being sent over this.
Because we do use the internet for phones as well.
Right. And in fact, the internet is what's being used all the time
So
for phones.
is whatever we're using for phones now going to be obsolete?
No. It's just that the internet is getting bigger. He's just making it bigger, and he's making it cheaper. And so the phone calls to India will get cheaper. You know, it's
But they're already free.
no, not to India. When you call India, it's not. Oh, yeah. When you call India via Skype, it's free.
Or WhatsApp, it's free.
That's right.
The internet, so we do have that.
Yeah, we do. But if you try to call a cell phone in India, okay, in other words, they charge you for the additional leg. There's one more leg. I'm calling my daughter. She lives in Istanbul. I call her on WhatsApp, but if I want to call her on her phone and have it ring through the cellular network in Istanbul, I get charged.
But you said this isn't the phone, this is the internet.
But it's just data. Data, the internet. The phones use the internet to transmit your voice these days.
Right.
But you don't know that.
But
Well,
if we have that, then we don't need that.
Well, but people are using the internet for everything, you know, cooking shows. I mean, do we really have to waste internet bandwidth on cooking shows? Surely, because there are thousands of people who want to see cooking shows. So the amount of data that we're using is constantly increasing for the videos, for the voice, for all the streaming stuff that we do. I'm getting this stuff right here. This is not on my computer, this is coming from the internet. It's coming wirelessly to my computer, and it's coming via ground lines to the router that's upstairs. You had a question? You have a couple.
Yeah, why aren't these satellites being pulled into the Earth's gravitational field? And that goes for the Iridium also.
Why are they being pulled into the Earth's gravitational field? It's the same reason that any satellite. I'm going to give you this. This is short shift here, because the question is general. Why does anything not fall into the sun, or the Earth, or the moon? And that's because it's in orbit around it, and the orbits tend to be consistent. They go around and around and around, and they don't fall in. So that's the short answer to what otherwise would be a very good question in a different context. Right? So, sorry. Yes.
A couple of questions. If a person is on the Earth,
If a person-
beneath thousands of these things,
If a person is on the Earth beneath thousands of these things,
yes, and you look up,
and you look up,
do you see things that are moving as if they were stars?
Yeah.
That's the
yeah,
first-
these low Earth orbiting satellites, you can see them as the sun sets. Okay, and so the sky is now dark, but the satellites are in sunlight. But the sky is dark above it. You can see at sunset. You can see many of these satellites traveling across the sky, even in New York City. You just have to look up. They're there all the time.
So a human being can see it,
Can see it.
and an observatory can see it.
Yeah.
Does it ever, as it's moving, does it ever block information, or is information misinterpreted because they're seeing this thing up in the sky.
Are we
An
misinterpreting
observatory
what?
think it's a new planet, or will a human being think it's a UFO, or?
Okay, are these satellites being,
Things are up there and moving, and are they blocking things beyond it
are they blocking things beyond it? Well,
as it's moving by? It blocks
a satellite can block a star for an instant.
Yes,
Happens all the time,
right.
every day. But I don't think anybody's being confused by it because it's just technology. So the fact that there's these things up there, we know what these things are. There was a spacecraft that did for a short while. It was busy. Its job was to get to an asteroid way out there, and it was spending 7 years doing it. And in order to do it, it had to come by the Earth every now and then, get a boost from the Earth, and go further out, and then come back to the Earth, get another boost, and go further out. One of the trips in, it got mistaken for an asteroid. Okay, and for a day or two, they thought they added that asteroid to the list of the millions of asteroids that are known, and it took them a day or two before they figured out that it was a spaceship. Okay, so in that sense, there has been a mistake made. But otherwise, no, people don't make it. Those are satellites, those are not. You know, not a big deal. So what do you think? The fact is that what these satellites do, and I'm not going to run the video now, I guess, but what these satellites do is they're talking to one another. If you want to get from here to here, if you want to send a packet of information from here to here, this video will show that the lasers will link up like this and 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 like that, and then down to the ground. There may be 6 or 7 or 10 hops using lasers. These satellites are literally pointing at each other with lasers and sending the data over lasers to the next satellite and then down. So, and this is going to be done thousands of times per second with thousands of different packets of information. It's really a technological feat, and it'll be up there in a couple of years.
I have a question.
You have a question?
We've passed a number of tipping points in climate change. We know that the Earth is in for a disaster if something radical doesn't happen, which it won't.
Right.
And people...
So is this a tipping point? What kind of tipping point? No.
My question is, all of all the money that's being spent on all of these things, we should be building dikes. And
that's not a question. I agree with you. We should be building dikes, but this is not a dike.
No.
This is.
But it's part of the tremendous amount of money that's being spent.
Yeah, but this is being spent by Elon Musk, and although he's not the government is Donald Trump, and he should be spending the money on a dike. Absolutely.
How is he making money on this?
Because he plans. The reason he's doing this, the guy's insane. He's doing this so he can make enough money to go to Mars. It's his idea.
So this is going to generate income for him.
He's going to make. I read this. He's going to make $5 billion a year selling space launches. He's going to make $30 billion a year doing this. Okay, you want to invest. If you can invest in SpaceX, do that, because if this thing gets off the ground, it's going to be amazing.
What's he going to make it on? You're going to have chaos on the Earth.
Yeah, but you'll be having people paying for it.